There are three components of whole blood: red blood cells, which are very dense, plasma, which is not very dense, and Buffy coat, which is just right. It's right in between. When you're presented with whole blood, which is a very specific term, you're receiving all of these components. However, they're intermixed, making what appears to be a homogeneous mixture. And that's what we call whole blood. We can centrifuge whole blood, which is a process that will separate things out by density. When we centrifuge whole blood, the very heavy red blood cells sink to the bottom. The platelets and the white blood cells, they form this little tiny strip in the center that's called the Buffy coat. And then everything in plasma that's rich in proteins, ions, water, that all ends up floating on the top as the least dense component. Plasma, which makes up over half of your blood volume, is, it's mainly water and proteins. It's water mixed with proteins, electrolytes, nutrients, waste products. Key plasma proteins include albumin, which maintains our osmotic pressure, globulins, which are mostly antibodies and transport proteins, and fibrinogen, which is a clotting factor. It's a clotting protein. If we were to draw blood and place it in a bag, this whole blood would contain red blood cells, white blood cells, platelets, and plasma. Centrifuging the blood separates it into those three layers: plasma at the top, Buffy coat in the middle, red blood cells on the bottom. Plasma seems to make up about 55% of your blood. There are a variety of different proteins present in the plasma of your blood, and they can be classified or categorized in different ways depending on what your physician is looking for. But we're going to focus on albumin because it is the most significant protein present in plasma. Albumin is a yellow colored protein that imparts its color to the straw like overall appearance of plasma. It's also albumin that turns the yolks of an egg yellow. It also gives it that characteristic rotten egg smell. Because albumin is the protein present in the most abundance, it also is the protein that contributes the most to the colloid osmotic pressure of your blood. And this means that albumin is responsible for keeping your blood in your blood vessels. Seriously, seriously. Albumin attracts watery components in blood vessels and in your tissues, drawing it into the plasma portion of blood. And this is a good thing that you want albumin and your watery plasma to remain in your blood vessels. Remember what I say, people. If your blood is not in your vessels, you need to see a doctor. There's a pretty large amount of globulins that are present in your plasma at any given time. Most globulin proteins are transporters of some sort, such as transferrin that transports iron, and the thyroid binding globulin that transports thyroid hormone. There are 5 classes of immunoglobulins, which are more casually known as antibodies, but those are globulin proteins. Rivaling the importance of albumin is a protein named fibrinogen. And this protein is soluble in water and is also soluble in your plasma. When needed, fibrinogen can precipitate out of the plasma by turning into fibrin. And this allows it to glue together broken capillaries and basically act like a band aid. 90% of your plasma proteins are made by the liver. So, liver malfunction results in a drop of osmotic pressure or colloid osmotic pressure of your blood. This ultimately leads to edema and a specific condition called ascites, wherein massive amounts of fluid accumulate in the peritoneal cavity. This is also what accounts for the swollen belly of many people who are nutritionally deficient, as nutrition is of paramount importance in making your plasma proteins.